That's better. Alright, and we're live for the one person. We will wait a minute or two. We're a little bit early to get started. Hope everybody had a good lunch. Saw everybody got in the classroom and did their lesson. That's good. Just doing something on another screen while I wait. Alright. Alright, let's get us started. Alright, so we're getting started. Without using any exceptions, generally the smallest aluminum conductor permitted to be connected in parallel is blank AWG. I'm going to start out by looking up parallel conductors in my code book, because that's going to be just that should get me pretty close. For those of you not familiar with what this is talking about, installing in conductors in parallel is whenever you have something that the math says would require 1,000 KC mil wire, and you do not have the resources to pull a wire that's 1,000 circular mils. 1,000 KC mil, not 1,000 circular mils would be like smaller than these wires. 1,000 KC mil is bigger than a water hose. So I'm looking up paralleled, alternate sources, circuit breakers, conductors, C conductors, comma, parallel. Okay, so I want to go back to conductors. Conduits, conductor, connections, connectors. So I need to go the other way. Conductors. Now in parallel under conductors, I was on the right page. Pendant, paralleled. So there are a lot of articles. This is where it's going to help to know how the code book is laid out, because there's probably 10, 15 different options for this one. It would help to know that Article 250 is grounding and bonding. So you can cut out the Article 250 sections. 300.3, 300.5, 300.20, those sound reasonable. 310.10 also sounds reasonable. So let's start with that. These should all be right in the same section of the book. 300.3, 300.3, 300.3. Well, I just happen to flip to 310 first. Be sure to keep the 310.10. That's on this page. Uses permitted. 310.10H. GH. Conductors in parallel. No, there it is. Conductors in parallel, general. And this is under the conductors for general wiring. Aluminum, copper-clad aluminum, or copper conductors for each phase, polarity, neutral, or grounded circuit shall be permitted to be connected in parallel, only in sizes 1/aught or larger. So that's 310.10H. Oh, look, there it is. Which of the following tables provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, were not more than 3 current-carrying conductors installed in a raceway cable or earth based on ambient temperature of 60 degrees Fahrenheit? We went over this table so much last class, 310.15b16. If you do not have this table marked in your code book, mark it. This is one of the more important tables in the entire code book. When insulated conductors, they must be listed and marked as being sunlight resistant or being covered with insulating material, such as tape or sleeving that is listed. This seems true. 310.10D. So that's just the installation of conductors. Conductors for general wiring and installation, 310.10D, is locations exposed to direct sunlight. I would look in the index as conductors in direct sunlight, and that should send you right here. Next up, conductors used for direct barrel applications are generally required to be a type identified for such use. Yeah, I do 300.5, but maybe not, because 310.10 is installation. Direct barrel conductors. 310.10F covers that. Figured before I flipped away from this page, I should, look at it. Because this is covering conductors for general installation. Alright. More than one ampacity applies for a given circuit length for conductors rated 0 to 2000 volts. The highest value is generally required to be used. Oh, I misread that. I thought that was saying where more than one ampacity is being applied to a set of circuits, which didn't make sense, but I was like, sure, if you're in a weird situation where there's more than one ampacity for a set of circuits, you would use the highest. But this is if you're using number 12 and number 10 in the same circuit, you have to use the value for the number 12 whenever you look up your ampacities. Alright, yeah, that makes a whole lot more sense. Alright, where run in parallel in separate cables or raceways. The cables or raceways with conductors are required to have the same number of conductors and shall have the same electrical characteristics. Oh, parallel. So we're going to flip back to that parallel page, 310.10H. There's some exceptions. So then there's 310.10H2, conductor and installation characteristics. It's important. We've done enough DC theory to know about whenever you have different lengths, they're going to have different resistances. Whenever you have different resistances in parallel, the one with the lower resistance is going to have more amperage. And that might spike the amperage up on one leg. And we're talking about drastically different distances. We're not talking about like I formed them into the box in a neat way and I had to cut off 6 inches off of one of them to make it form correctly. We're talking about I was running the conduits and I had to run one of the conduits a different direction and come around the other side of the building to get where it needed to be. Or something like that. I'm not entirely sure what the situation would be where you would run drastically different lengths, but it's important that you don't. Maybe you're trying to use something already installed. Uh, I guess that would be the most reasonable example is where you have like two big motors installed and they're like 50 feet away from each other and you want to eliminate one of the motors and put a bigger motor in the other spot. So you're like, I'll just parallel it, and you just run a conduit to extend that wire back where it had gone. It would be smarter. Like, it's stupid to do it that way because in the mental image I have, because you could just shorten those wires and like remove conduit and move it back to where you're at. But in the mental image I'm having, the way that they're doing it wrong is they're just running a new conduit back to where they were and installing it. Maybe that would be done for a temporary situation, but that's a lot of work for something temporary. And that's the philosophical thought for the day is don't do a lot of work for something temporary. All right. Neutral conductor is rated 0 to 2000 volts that carries only the unbalanced current from other conductors of the same circuit shall be required to be counted when applying the provisions of 310.15b3a. I would go to that section 310.15b3a. That's a table, I believe. Okay. And if you look at 310.15, probably B. Yeah, B5. That is neutral conductor. Is it here? Yeah. A neutral conductor that carries only the unbalanced current from other conductors. Ooh, crushing it. My code book, not this. Uh, shall not be required to be counted when applying the provisions of 310.15b3a. And it's spelled out specifically right there, and that is 310.15b5. But it's on the same page as the table 310.15b3a. Except as permitted elsewhere in the NEC, the minimum size copper conductor rated 0 to 2000 volts according to Part 3 of Article 10.310. Oh, that's number 14. If you look on table 310.15b16 of all the can't talk, of all the wire sizes, number 18 is listed, so you will need to go a little bit deeper. Should be conductors for general wiring. And I would look up wire size is where I would start looking things up. Scope. Aha. Let's see. Nope, that's parallel. Let's look at the explanation to cheat. 310.106a. That is, yeah, that's a good spot to look for that information. 310.106 has a bunch of good information. It's some tables. Uh, but there are... Oh, 310.106 is not tables. It is just conductors. Minimum size of conductors is there. And then conductor materials. And it also covers 310.106c covers stranded conductors and what sizes need to be stranded. So 310.106 is where all of your like conductor requirements are going to be. Type THHW. Okay, so 310.104, table 310.104, it covers every single type of insulation that is possible and all of its attributes. And you would look there. It is 90 degrees in a dry location. Generally wet, uh, wet location wires, so wires with a W. They are 75 degrees in a wet location and 90 degrees in a dry location. If they have the -2, they're 90 degrees in a wet location. Dissipation. I don't know if this is in the code book. Yeah, I don't think it's in the code book. The principal determinants of conductor operating temperature. So what this is talking about is where does the insulation rating come from? Like the temperature rating for the insulation. And it has to do with the rate of heat dissipation for that insulation and when it's going to start melting whenever it fails to keep the temperature in. All right. That is that for this one. Let's see. Tom joined us. Good job, Tom. All right. Let's do lesson 5. Yes, lesson 5. I will see you guys at 3:45. I'm not going to shuffle the questions on this one. Don't feel like it. All right, you guys have a good time on this. I will see you guys in a couple hours. Let's end this stream here.